So welcome to the third episode of the 𝐒𝐞𝐻 podcast. I'm here with Dr. Sally Goldin. Perhaps you can start just by introducing yourself.
Thank you, Justin. Well, I earned my PhD from Carnegie Mellon, the birthplace of artificial intelligence, quite a long time ago, during the first golden age of artificial intelligence. At the time, people were building systems that could do reasoning and planning, also systems that captured and could apply the knowledge of experts like doctors or scientists. When I left Carnegie Mellon, I actually went through a variety of different careers. So I was a researcher in cognitive science for several years and then felt that I wanted to work on more practical problems. So I moved to a career as a software engineer, worked for some of the major US companies like Digital Equipment Corporation and Polaroid. And then in 2003, I came to Thailand and started working as a professor of computer engineering. I also have some entrepreneurial experience. I've been involved with several startups, and one of them created the first remote sensing software for analyzing satellite images that ran on an off-the-shelf PC at a time when PCs had very, very little computational power. Most of you won't remember that.
As a student, I think one of the hardest decisions is, what do I study and why? There's so many things that you could study. And you started as a researcher in cognitive science. What drew you into that field?
I got hooked by a class that I took when I was an undergraduate. And at that time, there were a lot of interesting theories about cognition, about learning, about memory. And people were just starting to use computer programs as a way of simulating or testing cognitive psychology theories. And actually, that's why I ended up going to Carnegie Mellon, because they pioneered that approach. So my PhD is actually in cognitive science, but we work very closely with the computer science department.
My thought on this was that cognitive science, when you combine it with your practical choice of software engineering, if you combine cognitive science and software engineering, that might be a pretty fair way to say artificial intelligence. It seems kind of interesting that you ended up in artificial intelligence, which is almost coming back home to cognitive science thinking.
I have been amazed since I came to CMKL, which by the way was about 2.5 years ago, at how all my early life choices are starting to echo back into my current life, including the fact that my dissertation was basically a machine learning type of dissertation, looking at what kind of stereotypes people had about what different kinds of criminals look like. This is exactly the sort of thing that you could answer using deep learning today. So yeah, I have to agree with you.
Well, this is actually a great transition to what is the main topic of conversation today, which is, what is AI exactly? And maybe before we get into the misconceptions, you could tell us what your thoughts are, best attempt at a definition of AI.
There's actually a classical definition that certainly it was current when I was in graduate school, which is artificial intelligence is artificial systems that can solve problems that are usually viewed as requiring human intelligence. So this could involve complex learning, reasoning, language understanding, decision making, all of these tasks that we have viewed as being the sort of the domain of human intelligence. Artificial intelligence is trying to build systems that can, at least to some extent, provide the same kind of problem solving, the same kind of task performance.
You know, it's interesting, as we move towards the misconceptions perhaps in AI, when I was listening to your definition of that, my immediate thought was, perhaps we project emotion onto our expectations of what AI would be. Your description there had the cognitive component, problem solving, but not say, frustration with not solving a problem, which might fuel problem solving or maybe hinder it. I don't know. What are your thoughts on our tendency as humans to, anthropomorphize, to project?
I think that that's actually an issue with the current status of artificial intelligence. We're sort of jumping into talking about the hype, basically. But I would think if you asked anybody on the street about AI now, what they would say immediately is ChatGPT. And if you have a conversation with ChatGPT, you immediately realize you are reacting to that artificial intelligence system which one can argue doesn't actually have anything like human intelligence behind it, that it's entirely a probabilistic system that has been built using an incredibly large amount of information, but you react to it as a human, as if it were a human with intentions. And that's kind of normal. We need that as humans to be able to interact with our fellow human beings, but we do tend to project that onto computer systems as well.
That's so interesting. I actually want to dive way more into this, but before we do, I should make sure we get to the script here of stable diffusion, DALL-E, generative AI, this kind of trend of popular news and how perhaps they market it versus what your interpretation of its actual capabilities are. How would you describe that cat?
Well, I think that generative AI has amazing capabilities, that the growth in the capabilities of image generators, large language models, computer programming systems like Copilot has really been astonishing. So it's not surprising that people are wowed by this. And I would say that part of the issue is that people do attribute certain kinds of human characteristics to these systems and expect them to behave in certain ways and expect them to be trustworthy, for example, or to give you accurate answers because they seem to know what they're talking about. And then that isn't always the case. Okay, so that's kind of part of the issue, but it's not that generative AI is trivial. Far from it. There are many areas in which it could provide a lot of utility, but I personally feel that it's the fascination with generative AI, because it's so flashy, is making people not really realize it's just the tip of the iceberg. The majority of applications of artificial intelligence are much less flashy and are way below the radar, but are nevertheless extremely important. In fact, artificial intelligence works best in domains or in situations where humans cannot do the task. And this is particularly the case when there is so much data, so much information that needs to be processed, that a human certainly couldn't handle it in a finite time. Artificial intelligence systems, in particular the segment of artificial intelligence is called machine learning, is incredibly adept at detecting and extracting subtle patterns from large amounts of data. But this is a tremendously useful capability, and it is being used in a wide range of areas. For example, you may have seen some of the news articles about people who were amputees or people who have, like, say, quadriplegics or paraplegics, being able to operate prosthetic limbs basically by their mental processes alone. This has been a sort of a holy grail in assistive technology for a really long time. It's now become very possible because of machine learning. Why? Because machine learning can be applied to the extremely complex EEG signals, EMG signals, other electrical signals from the brain, extract the patterns that are associated with goals and intentions, and then interpret those in order to animate, let's say, an artificial arm. Other examples include discovering new pharmaceuticals or new materials. Machine learning is being used extensively in science and technology. In my own area of research, machine learning has really revolutionized remote sensing, which is the use of satellite imagery to extract information about what's going on the Earth. We can now gain really detailed knowledge, let's say, about the effects of climate change over time by analyzing dozens or even hundreds of satellite images that would just not have been possible using classical approaches.
While you were talking about this, I was kind of picturing a Venn diagram, what humans can do and what AI can do in this overlapping space in the middle. And I was thinking something along the lines of humans can abstract creatively to make some kind of a use case, some kind of a premise that's applicable to our own well-being or our survival or the well-being of others. And we can only have a limited ability to actually do this idea. And then it's almost like there's a handoff that happens if we can give an AI the use case and some structure with how to apply data to that use case. It can do now more than we can on the other side of the Venn diagram. And so maybe AI should be called applied AI or something. It can't abstract, but it can apply better than us.
But it can abstract. I mean, finding patterns is, in a sense, a kind of abstraction. But I certainly agree with you that AI is going to be most useful when humans are in the loop and people are working closely with it. And I am concerned that that is not something that many people who are in the 𝐄𝐩𝐢𝐬 phase about AI really believe. I'm particularly concerned about AI writing software. Being a software engineer with many, many years experience, I can see that code generation systems can be useful, can probably speed up the process, but the fact of the matter is that the characteristics that make software stable, robust, easy to evolve, functionally correct, I do not think these are things that can be extracted from data. They depend on years and years of experience to understand. But I think there are a lot of programmers who think and I read in like ACM and so on, articles that say, well, are all programmers going to lose their jobs because all the programs are going to be generated by AI? And all I can think of is, heaven help us if that's true. Software has enough problems already when humans are writing it, and if people stop taking responsibility for their own code and start relying on ChatGPT or Copilot, I think I want to go live in like a little village where I don't have to deal with.
We'll set you up on the moon somewhere because they're.
Well, I don't know about that because if you're on the moon, you're definitely very dependent on technology. This is a great transition to the next topic, which is issues in current AI, and the key word that I extracted from what you were discussing there were a few, of course, but perhaps it's accountability. Accountability as it might apply to ethical issues in AI or social issues in AI. What are your thoughts on AI being used unaccountably and maybe having ethical issues in regards to access and other things like that? You don't want to hear this. It'll take hours and hours, but
sorry, we have great editors here.
Yeah, I'm extremely concerned about the current situation in AI, particularly in the 𝐄𝐩𝐢𝐬 area of AI, because that's where it's getting the funding and that's what's getting people's interest. So currently, in order to produce, say, a large language model like the models that power ChatGPT, you need huge amounts of computing resources, incredible amounts of electricity, which of course is not good for climate change. What this means is that the progress in AI, if you measure progress by these flashy applications, is being made primarily by a handful of very wealthy companies who are opaque in making decisions that are not really necessarily in the public interest. So there's no mechanism right now to make sure that, if you ever could make sure, that artificial intelligence is going to be applied to solve real problems as opposed to suck people's data out of them in order to sell them things, which I don't think is extremely worthwhile.
It's almost like sucking their data out of them and then using it as a club to suck their wallets dry as well.
Not only that, I don't know how aware you are about the recent release of the mobile ChatGPT. Free mobile application chat, and of course this is particularly exciting to people because the earlier version of ChatGPT, the first version was free. Second version they started to charge for. So now, we get it for free, except everything that you do goes back to OpenAI. And I don't want to necessarily just pick on OpenAI because I'm no friend of Google or Facebook either, but I feel, accountability is definitely one view there's no sense of responsibility as far as the final outcomes. And the benefits of AI are not necessarily going to be equitably distributed when it's controlled by a few big companies. Okay, there's lots and lots of other issues that concern me as well. Most people have heard about the serious problems with bias and fairness in AI models that are making decisions, because one thing about machine learning, it's true of human learning as well, but machine learning will find the patterns in the data that you give it. So if you give it data that basically reinforce societal biases or prejudices, then the decision model that arises will naturally embody those prejudices. There's a lot of serious questions. And one thing that bothers me a lot is that because of the OG wow factor, people don't think about these things. I would say that the average person, and maybe even the average student coming into our program, does not really appreciate the risks. They only see the fun, the excitement, the flash. And most of them are also really unaware of these more, I won't say prosaic because they're equally important, but less publicized benefits that are coming from machine learning.
Yeah, that's really interesting. The OG wow factor is when something new and exciting and disruptive emerges, there's this small time window, or maybe not so small time window, where we're all kind of blinded by the potential and we overlook the risk.
I'm not even sure that it's potential, because I don't think that most of my students who love ChatGPT have any notion that it would be useful, except maybe to cheat on some essay or something like that. I think that people are just astonished by the level of performance that generative AI can provide. And I am particularly amazed by the image generation. I have to say that many of the images that I see that are generated by Stable Diffusion or DALL-E or Midjourney are amazing. They strike me as being art. And that actually puts me at odds with some of my friends who are very concerned about the issues of plagiarism and copyright, and the fact that many of these models were trained without permission, which I definitely, that concerns me. But I have an OG wow factor. I don't have an OG wow factor about ChatGPT. That's partially because I write fiction, and I've written all my life. I don't believe that ChatGPT can write better than I do, no matter how much data they feed it. But I've always liked to draw, and I've never been that great at it. And so when I see what the image generation programs can produce, it's very exciting. But it's not going to solve world hunger. It's not going to help with climate change. In fact, it's probably making climate change worse, right? It's not going to reduce income inequality. It's not going to help us in the next pandemic, although AI very definitely could, but generative AI, not necessarily.
Yeah, that's very interesting. As a writer myself, I can relate to what you're saying. Now I can write my way into a prompt that can create the images I always wished I could draw. You actually had alluded to our students a few times. I think this might be a good time to jump into the AICE program, because the OG wow factor, perhaps the best defense against the OG wow factor, is knowledge, is learning what AI actually is, what it can actually do, what the constraints are, and maybe what our constraints are in the use of AI as well. So, AICE goes beyond the hype, one would hope, in that our students get exposed to a lot of different approaches to using AI. So how would you describe the curriculum design, the curriculum development behind our students' engagement with this new technology?
Well, the first thing about our program that's really exciting for me is that students get to work with AI right away. And before I came to CMKL, I worked at another Thai university, and everything was basics in the the first, second, and third years. You couldn't do anything really advanced or interesting until you got to be like second term junior at the earliest. So our students really dive in. We don't just focus on machine learning, generative AI, deep learning. We have competencies that introduce students to the range of different AI technologies, including classic technologies that are still relevant. Things that I learned about when I was in my graduate program. The other thing that really, I think, stands out about AICE is we don't just teach AI, we focus on AI engineering. And what that means is that we want our students to recognize the truth that an AI model by itself can't do anything. AI models, machine learning, generative AI have to be embedded in a complete computer system, which means that our students need to learn about traditional computer engineering topics like programming, hardware and software architecture, databases, security principles, user experience design, and so on. So our curriculum also includes those competencies. It's not just AI, and of course the name of it is AI and computer engineering. The other thing that I really get excited about is that the program is very hands-on, very project-focused. So our students start working on R&D projects, system building, from their very first semester, which is a tremendous opportunity for them to apply what they're learning in the classroom, but also to dig deeper and to learn on their own. And one of the things that is very scary is that technology as it stands today and technology the way it's going to be when our students graduate, very different. So our students have to have these skills and the level of comfort to go and dig deeper or look further.
You know, my father always said when I was debating whether or not I should go to university, whether or not I should get a graduate degree, he'd always emphasize, well, you don't actually go to these degree programs to learn something. You learn how to learn. The project basis is what actually allows this to work. I think the project basis allows the students to apply their knowledge and watch how their knowledge can quickly fall behind the projects they're working on, prompt them to address new problems that perhaps even you and we haven't been exposed to yet either.
And it also teaches them that there are no boundaries. I mean, we can say, this is the curriculum, these are our pillars, we have 10 pillars, we have, a certain number of competencies per pillar, this is what we think you should be studying, but in no sense is this the sum total of what we could teach you about anything. And I mean, my goal is to get the students excited about this, excited about the process of learning, excited about technology, but also to make them be a little bit more critical, going back to the question of risks. So the other thing that I really do want to mention is the fact that we very consciously talk about ethics and risks related to AI. I mean, that's built into the program. It's difficult to teach that because you don't really understand it at a fundamental level until you're in a situation where you have an ethical dilemma. But nevertheless, it's not like some side issue. In my previous university, I believe that there was general education courses they have in Thailand. Okay, where everybody has to take a certain number of general education. There's a general education course about ethics, divorced completely from everything else they're doing. So when we evaluate their projects, we ask them, are there any ethical issues that are raised by this project? And if so, what have you done to mitigate the possible negative effects? So we try and get the students to think about this from a very early stage also. So our initial ethics competency is usually something that students will do in their first year.
Yeah, I think compared to a non-project-based curriculum, ethics can be much more effectively integrated when you're applying knowledge into the real world. That's when you start to really face the ethical conundrums. And the year 2 students, to my understanding, they do projects that have to have some kind of a positive social impact. Is that correct?
Right, well, the first year projects are focused on entrepreneurship and innovation. So the students have the mindset of, oh, I'm creating a new product. Okay, the second year projects, we try and match the students up with real world stakeholders who have some issue. And it's a wake-up call for them because many real-world stakeholders have constraints. So just to use as an example, over the past year, I have had a project where our stakeholder is a very small charity that works for the welfare of some of the tribal people in the north of Thailand. They go in and they build irrigation systems, they build water supply systems. And so we wanted to build a map for them so that donors could understand how the geography of northern Thailand makes this a difficult problem, okay? Because northern Thailand is very, very rugged territory, rural, not a lot of roads, okay? But one of the things we face is the fact that this charity, they can't afford to pay Google Cloud to run a server. So we had to figure out a solution that would be affordable to a small charity. So yes, I think the second year builds on what the students learned in the first year. And then our third year, we're branching out to provide a variety of different kinds of experiences, but one thing that students can choose is to explicitly do some AI-focused deep tech research. Because there's no real requirement during the first 2 years that they have AI in their project. Some of them do and some of them don't.
You know, it's very interesting, the project-oriented curriculum and the idea of constraints. I think that's exactly right. And from the creative industries, one thing I learned that was counterintuitive was that creatives are more creative if you constrain them a bit, if you can put constraints on them. I used to tell writers, if you want to be a writer, you have to write for somebody else. Because if you write for yourself, you'll sit there until it's perfect, and nothing is ever perfect. So I think in summary, AI is both exciting and scary. And I think, correct me if I'm wrong here, but the OG wow factor, what we really want to do is subdue the OG wow factor a bit and replace it with knowledge of the real constraints that AI has, both ethically, technically, while also realizing the limitations of ourselves. So what are your closing remarks on that?
My goal is to broaden the view of the students, to broaden the view they have of AI, to help them understand that, first of all, AI encompasses a very large number of techniques and approaches. Secondly, that AI can be applied in places they probably never thought about. And third of all, to realize, according to what I said before about the AI engineering focus, that it's not enough to be an expert on AI. You also, if you plan to be a practical AI practitioner, if you plan to go out in the world and actually build AI systems, then you need to know about traditional computer engineering topics as well. You need to know how to program. You need to know how to design a system. You need to know about databases and so on. So, I hope that when our students leave, it's not just that they have more knowledge, but they have a really different perspective.
So I think we should thank Dr. Sally Goldin for her insights on AI. And I think it's really, to maybe bring this full circle, I think it's really interesting the way that you went from cognitive science into software engineering. So maybe a last bit of advice for students or parents of prospective students who are wondering, what should I do with my life and why would AI be an interesting field to study? Maybe you could give an inspiring last comment here on what it is that inspired you, or maybe what it is that inspires you now about the future of AI.
I don't think anyone should expect when they're 18 years old to know what they want to do with their life. And therefore, I have a saying, or sort of a motto for myself: joy is a signal that you can trust. What do I mean by that? I mean that if what you're doing brings you joy, even if it's really difficult, and let me say that our program is not easy, if it brings you joy, if it's satisfying, if you feel like it's using your skills, if you feel like it's making you grow, that's what you should be doing. And I don't necessarily think that every student can make that decision the first time. And certainly my own career path has been quite convoluted as I discovered different things that gave me joy.
A very inspiring closing remark. Thank you again, Dr. Sally Goldin, for joining the TechSites podcast.
Thank you, Justin, for asking me.
And let's all go ahead and like, share, subscribe, and tune in next week for the next episode. Thanks for tuning in.